Hello and welcome to the second Data Product Workshop. My name is 𝗔𝗰𝗋𝗡𝗋. I'm the co-host of the Data Product Workshop. Today's webinar is titled Composable Language Models, Why You Don't Need 100,000 GPUs. And it's brought to you by Jon Cooke, the CTO of Dataception. So I'm going to hand over to
Appreciate that. So hi everyone. Yes, our second go at the podcast today, or the Data Product Workshop. You know, we're still figuring stuff out, so bear with us a little bit. So yeah, great. Thank you for joining, and yeah, it's a really interesting topic today. So yeah, composable language models, small composable language models, and it's quite interesting that there's obviously a massive boom in large language models, but actually we don't need them necessarily. Don't need the big 130 billion type models. So we'll talk a little bit today around kind of what small language models are, some use cases, some considerations going through. It's not going to be a hugely deep dive. Obviously, we're going to try and give you like an overview. I've had some obviously feedback from the last one, which were it was quite long, so I'm going to make it a bit shorter. Obviously, you're going to have plenty of time for questions, so I'm looking forward to your questions at all. So basically, what we'll cover, effectively, I say, this is going to be an overview. We're going to look at sort of what small language models are from a high level. We're also going to look at the intersection of small language models as data products and how the whole composability aspect comes in, which I think is super interesting. We're going to look at some example use cases and some we've actually built and delivered over Dataception, and then we'll look at kind of how we go about building these small language models and look at performance, look at reducing costs, that types and time considerations as well. And then we'll do a summary and questions at the end. So hopefully that all will be good. But what we're trying to do, the overall theme of this is obviously, Llama 3 has just come out. We've seen these massive language models, and they cost millions to build, millions to train. But obviously, a lot of use cases, we actually don't need that. So we'll try and dive into that and give some examples and kind of give you some options around that piece. Right, let's start. What small language models? Now, I'm guessing a lot of people on the call know about large language models, but small language models, what are they? Well, succinctly, they're compact specialist versions of large language models. So fundamentally, they are, designed to be efficient. They're designed to be, small amounts of computational resources used in them, compact size. So you hear the big headlines: 130 billion parameters, 100 billion parameters. Small language models typically are much lower than that, and they can go down to like tens of millions of parameters actually, and we'll talk a little bit about that later. But typically they are in the sort of 1 billion to 7 billion range. They're designed to be resource efficient, so there's lots of interesting mechanisms inside the layers to actually make them, like a mixture of experts, to make them much more, efficient on computational power. They're trying to be fast, so you want second, 2 or 3 second inference time. So due to the smaller size, you're not going through the massive layers. You're trying to be basically, put them on not just these big GPU farms like CPU, commodity kit, Macs, that type of laptops, that sort of stuff. But they are optimized for specific use cases. So the smaller models tend to be less flexible, as we talked about the limitations. They tend to be for very specific use cases, although we're starting to see some interesting ones around, like Microsoft just launched 𝗖𝗺 3, which is actually a general model. We've seen some of the smaller, the tiny Llama models as well. But typically, they're designed for specific use cases. Easy to fine tune, take less time, less data, that type of stuff. And one thing we're all should be interested in is the lower environmental impact. So obviously, if I'm not using 1,000 GPU solutions to do this, it's going to be much better for the planet. Cool. Obviously, one of the limitations, they can be less accurate, but actually, interestingly enough, if you're doing specialist use cases, they can actually be more accurate in some cases because you're training for specific tasks rather than the general piece. So let's talk about some examples. So yeah, we've already talked about Microsoft 𝗖𝗺, which is it's a mini. It's funny, isn't it? A few years ago, we were talking about 3.8 billion model being very large. These days, it isn't, but actually, it is small. But it actually still has a lot of tokens, 3.3 trillion tokens. Run on a smartphone, has a really large context, which means you can do very large prompts, you can do very much input data, and actually the model size itself, I looked at it, checked it out, it's like 2.5 gigabytes, which is tiny compared to some of the big models. But it is a general purpose model. BERT topics, a really interesting one. We're really taking out interpreting topics from text. So if I give it a bunch of text, it actually extracts out the relevant topics of it. Again, small, tens of megabytes to 1 gigabyte. There's also some existing, natural language models like OpenNLP, which is using for very specific NLP tasks like sensor detection. Again, these are sort of tens, to hundreds of megabytes of the models, but they're very good there for a specific task. Another version of BERT, and BERT is a very, very popular, very mature type of model architecture, and another variation of that, something called dstilBERT, which is actually a knowledge distillation version, which is a way of compressing it. Again, very lightweight, single-digit gigabytes, which is again comes under the small language category. Something I've used personally is a Microsoft Table Transformer, which is a very small, tens of megabytes model trained on 1 million table to actually look at documents and take out documents from particular, or take out tables and identify them. And of course, we've got the small quantized versions of the larger models, Llama 2, Mistral, these sorts of things. Again, they're quantized down, they're smaller, 7 billion, still fairly small in the language models, but they're typically single-digit gigabytes. So these are kind of a range of these sorts of things. And again, some of the use cases we see, these new ones coming out tend to be multi-use cases. We have some very specific ones like 𝗖𝗺cie, which uses Roberta underneath, again for fine name entity extraction. But topics we talked about, taking topics out of things like open-ended survey questions, we've seen that as well. What's everyone talking about? OpenNLP, we use OpenNLP for extracting sentences from emails. We've seen use cases with things like dstilBERT for doing sentiment analysis on Twitter data, and of course we talked a little bit about the table transformer, which is about identifying tables on legal documents. This was a use case we looked at earlier last year. So we talked about language models, but then this is also about data products. So what are they? Now, obviously, there's a lot of contention in the industry about what they are. The way we think about a data product is we talk to a lot of business people. So fundamentally for us, a data product is more about the product than about the data. It's basically trying to drive a business outcome. So fundamentally, you ask a business person, so what's my investment performance? Oh, that's a metric. So the product is actually a metric. What's my future cash flow? We talk about forecast predictive models. How do I avoid risk of failure? That could be a simulation. What do I do next? That's a decision model. And then the data that underpins that is what we call data services. So again, I know it's not totally aligned with what a lot of the industry is talking about. This is the way we frame it, because this is what we talk about when we talk about business people. So let's do a little bit of a deep dive into the technical aspects of data products. So the technical anatomy, we call it, the anatomy of data products. So fundamentally for us, it's a containerized component. So those are metric, a simulation, a model, a piece of UI that could go against it. So it could be a dashboard or a kind of like a visualization component, has an API associated with it, has its own specific pipelines, has its own internal kind of schema effectively. So you're packaging that up and then takes raw data from domain systems or for other data products, and all packaged up in a container, typically on Docker, because that's the way we do it, with the model, with the configuration, with the code, and actually gets deployed onto a cluster. So when we're talking about a data product, that's what we mean in the context of this particular presentation. So what does that look like from a small language model perspective? This is actually a high-level blueprint of a component that we actually built, and we are building and have actually deployed. It's a component, a data product, actually to take emails in using a language model to actually extract data out of that email, and actually then present it, put it into structured data, and then publish it off to an event bus. So it's really sitting in a kind of an integration pipeline. And if you look at the way, the different components of that, at the very bottom, we've got a connector to the email server. It then brings in the data, periodically polls the email server, brings the data into a kind of its own internal representation of those emails, creates a pipeline, so checks if the things have been read or not, and takes the unread emails, pushes that into a small language model. So we're using the 7 billion Llama 2 model, quantized down to 3 gigs, so it's deployed. And also, we're using a vector database that actually deployed as part of the data product, which is kind of interesting. So it's all packaged up together. So the email goes into the vector database. The natural language model is then used to query that using the RAG process. Then the output of that is then constructed as a JSON object and pushed onto an event bus. And this happens, again and again and again. So it's again a really nice kind of very simple example of a small language model deployed as part of a business use case. So how do we use them? So finally, this is what we've talked about, what they are, kind of how they're constructed, how do we use them? So taking a bit of a step back away from kind of AI world, we use a particular business process where we called the data product pyramid, which you may not have come across. If you go on my LinkedIn page, you'll see I talk a lot about this. And one of the really things that we always try and advocate is start with a business problem. Start with something you're trying to do outcome, rather than just go away and just build up an SLM or an LLM for kind of other purposes. Start with a business problem. So what we do is we look at a business process. We then use the pyramid framework, which is basically ask the decision, gets knowledge, information, and data, and they go down that particular chain of thought. And each one of those questions are asking, what decisions do you want to make? What kind of forecast do you want? What kind of metrics do you need? They come out to data product candidates, and we look at each of those and go, actually, is one of those good for an SLM, basically? So, for instance, if I wanted to do a forecast of a time series, go, actually, that's probably not a good model fit for an SLM. That could be like a time series forecasting. Or if we want to say, right, we want to do some content generation, that's a great example of an SLM. So what we end up doing is these different types of analytical components as data products. And for the SLM products, what we do is go through the classic kind of process of building those. So we check if it's the right fit. I think that's great. We then look at the relevant data, look at the types of models we want to use. If we're using RAG or fine tuning, or if we want to augment it in any way, we can label the data, choose a suitable model, build, test. And once we've done that, obviously then we harden the production testing and then basically operate as part of a normal AI type process. So typically we always start from the business process first. That's really, really key. And what you end up is this kind of the composable bit. So fundamentally, you've got your business process and you've got different models or different small language models participating in different parts of the process. It's kind of a very high level view. We'll go into the use cases, kind of how this looks in a second. But this is what the idea is. You have these small reusable components deployed as containers that can be adapted and reconfigured as the business changes. Fundamentally, you're not trying to put it all into one model, get one model to do everything, because that's obviously, unless you're a tech giant and got billions to spend, that's going to be tricky. And the idea is that we can plug them out and swap them out and change them as the business changes. And actually, then talk about training, how quickly that is, and how on commodity kit as well. So this is really, really, really important concept to get across. There's no deploying without some sort of infrastructure. So we actually, at data section, we have an architecture, and we're actually building a platform out to do this. So we talked about the containerization piece. So this is the very, very high level. I won't go into this in detail. I'll do this on another podcast, go into the architecture of this in much more detail. But fundamentally, it's based on sort of data mesh, data fabric type approaches. Fundamentally, each one of those data products is associated with a domain and business area. It gets deployed onto a cluster. That could be a multi-cloud cluster, for instance. So you could have different models deployed on different clouds. And then what's really interesting, we can actually orchestrate that through what we call a data product graph, which is actually another data product which actually links them all together. And we'll talk a little bit about that later on. But this is really important. So you're mapping out your business process using the graph, but then talking to all the language models as an orchestrated component across the organization. And there's some other components around part of this, which are things like the experience plane, the data product marketplace, the control plane, which is where all your data policies and data quality and governance, that kind of stuff. And then there's kind of the infrastructure. We have the orchestration engine. We have basically this concept of data fabric sits underneath it, and also on-demand cloud compute. So this is quite a key part of actually we had to deploy language models, these small language models, very quickly. But again, I'll delve into that on another podcast. So we talked about this data product graph, and this is again quite a really important part of the process. So fundamentally, as you're deploying these small language models, these components, you're actually doing that in tandem with other components like metrics, like classic decision models, like classic time series. And each one of those, when you deploy it has an API against it in a service contract or data contract, and that gets deployed to the catalog inside your application, inside the platform. And the graph then calls that based on a graph query language, which is something we're developing. And then what's really interesting, we've actually started putting things like functionary, which is a small language model just for doing specific function calling. So every time you deploy a data product, SLM, actually then you get this catalog of functions that actually then you can actually start asking questions. So what's my forecast going to be, as natural language from the analyst? And that actually executes the inside the small language model, that executes the graph, and actually then will then call the forecast model. I want to generate a report to do X, Y, and Z. That calls another model. So you get this really interesting interaction, being able to sort of query your enterprise through natural language using this kind of small language model approach. So which is super cool. Right, so we talked about kind of abstract. Let's start talking some use cases. So this is one we've actually we've done or we've been doing for a number of clients, and it's quite a classic use case we see for small language models or text mining. Now, fundamentally, here we've got an ingestion flow, and we've got on the bottom and on the right hand side we've got basically the query flow we just talked about. I'll concentrate more on the ingestion flow, and like I said, we do this a lot for a lot of clients. So we basically, the idea is that we're bringing in data from various types of text sources. We then do sentence extraction, so convert them into sentences. Sometimes you need to be able to chunk them up. We extract tables out of those. So look at the tables inside, because actually table extraction out of documents is actually quite tricky to do. We then extract all the data points out of them, push them into a vector database, and then be able to query them with the architecture we talked about before. So this is kind of the sort of the high level flow. If we actually look at what that looks like from a detailed flow, so this again is an example of what we've actually built before. So again, making this real, which is super important. So this is a use case we worked on. We were taking invoices in. We then basically used 𝗦𝗰𝗹𝗯𝗹𝗏 PDF, which actually extracts out the text of it, and we also used the table transform to extract out the tables in there as well. Both sets of those data went over to the using OpenNLP, which is actually a very small language model, to actually split up and chunk up into sentences. We push them into the vector database. All the sentences which were collated, put into the vector database, and then we use Llama to actually instruct to actually then query it into the JSON object and actually push it out, which is basically the flow of that data product we talked about earlier. So again, quite a simple use case, but it does show you we are using a number of small models here for different parts of the process. So, and it's all done on commodity kit. It's not done on massive compute farms, which is super interesting. Another one is credit ratings report generation. So again, quite a similar one, but actually we're actually not putting out a JSON object, we're actually generating a report. So the idea here is that it's a ratings engine. So investment grade financial instruments have investment grade have different ratings on them: AAA, AA, BBB, that type of stuff. And this is really a model to actually try and take data in, not just from market data, from like the classic data sources, but from like news agencies and sentiment analysis and that type of stuff. Build a scoring mechanism using classic AI, and we use a decision tree, and then basically generate a report using natural language generation, AI things, to actually try and shortcut the 6 weeks time it took to actually generate the report through manual people, risk analysts, to 30 minutes, which obviously has a massive implication for banks to actually be able to manage their capital if they can do that on a day-to-day basis rather than a month-to-month basis. So again, if we look at what that looks like from a tech perspective, from a small language model perspective, so what we're doing is we're taking in market data, which is classic time series, structured data. We're taking news articles in. We're using OpenNLP then to take those news articles to turn them into sentences. We then basically go through a feature creation component, which takes the time series and the text and actually turns them into vectors, into basically features data for the random classifier, which is a random forest one using classic scikit-learn. And then we're pushing it into a vector database again, putting the output of those into there with the underlying features data. And then we have a chat app, which actually analysts can actually then say, right, I want to be able to understand why Apple has been downgraded from AAA to AA, that type of stuff, and want to create this report. So the chat app actually then queries another language model. We're using Mistral here, the 7B one, there's a slightly bigger one than the previous one, then to generate the report. So again, we are using small language models in different parts of the process, but we're also combining that with AI, with classic AI, which is again really powerful. So again, one of the things we're trying not to do is to push everything, get the LLM or the SLM to try and do everything. You can actually use it for specific parts of the process. Okay, so obviously we've got this is using language models which we were using to straight out of the box. We weren't doing any tuning with that. This is another piece that we did last year, where actually we're trying to fine tune. So obviously we use language models out of the box, but actually if you want to add your own data in, there are a number of different ways of doing that. Obviously RAG is one of the ways which we just showed before. We put it into a vector database and be able to actually query that. This is actually where we fine-tune the data as well. And again, this is really interesting because we use a small language model. We use Roberta, which is actually a smaller version of, again, the BERT model. You see BERT coming up quite a lot. And it's 450 million parameters, so it's tiny in comparison to the big ones. But what we're trying to do is extract specific terms, name into extraction out of the documents, This is what the customer wanted to do. And what again, we go through the process. It was actually legal contracts, this was, and we then used classic Python code and libraries to actually extract out the text. We had training sentences and inference sentences. On the training sentences, we actually then labeled. We actually went through and labeled them. So this is a name. This is a date. This is a contract term. We had an existing set of entities like organization, geopolitical entity, dates, that type of stuff. But we also had new entities that we wanted to upload on there as well. And what was really interesting there, we used a commodity kit, so like a classic V100, EC2, 16 gigs, so it's not a huge GPU. And we were training each class, and each class took like 10 to 15 minutes to train, fundamentally. So every time we wanted a new class, it was a very short amount of time. It wasn't weeks, it wasn't months. And we had even 3,000 samples per class, and we actually had a very, very high accuracy rate on this as well. So again, another really great example of actually using small commodity kit. You probably could have trained this on a Mac 3, an M3 Mac, without actually having to go through large language models and amounts of CPU as well, and the GPU, which is really, really important. Okay, so we've talked about use cases, we've talked about training, so we talked about, so one of the big things around small language models, going from big language models to small language models, is optimization. And there are a number of ways of actually optimizing, what we call compressing large language models, going from like 130 billion down to either 7 billion, or taking parts of the model. And there are three typical types of ways of actually reducing the size of a model. There's something called pruning, which basically takes out part of the model fundamentally. So we're going in and looking at the weights and actually taking out the weights that actually aren't there, which reduces the size, but then actually can improve generalization. But it can, if you get too much on that, you cut out too much of the model, obviously, then you are going to get accuracy and performance issues. Quantization is probably actually the most popular one, where effectively you just take each of the nodes in the neural network are generally 16-bit or 32-bit floats. We actually then reduce those down to 8-bit, 4-bit, 2-bit, and I've even seen 1-bit, which actually reduces the model massively. And actually, interesting enough, it can lead a lot of loss of accuracy, but a lot of times the accuracy loss isn't huge. You actually sometimes see like 10% degradation, and actually for your use case that might be actually perfect. And we use quantized models a lot. There is also another approach called knowledge distillation. We saw this earlier with the distilled BERT, which is where you use a smaller model to be trained on a larger model. So what it's trying to do is learn the key patterns without actually learning the whole kind of taking on board the whole weights and that type of stuff. So it's great for reduction of that, but obviously there are biases in there. The training process can be quite complex, and it's really, the effectiveness is really based on the kind of the strategy, how you're going to do that. And it's not for the faint-hearted. We've done this a couple of times, and it really isn't for the faint-hearted. Fundamentally, the pruning and quantization are really the ones you really want to look at. And one of the best methods for quantization is something called quantized low rank adoption, Q-LoRa, and it's really, really interesting. If you look at a lot of the popular models which have been quantized are using this approach. And fundamentally, the idea is that you're combining two kind of approaches. You're applying a quantization approach where you're converting the weights down there, and you're also adding some extra kind of speed ups like double quantization, and also doing things like page optimizers, which put stuff in memory and kind of speeds it up quite a lot. And then we have something called the LoRa process, which is basically what it does. You're adding small extra layers to the model. So a neural network has a bunch of layers, effectively a bunch of neurons, and what you're doing is you're adding new ones into it effectively, and only training those pieces. So it's a much quicker, much less invasive type of way of changing the weights on it. And as you can see, something the sizes we get down for that is massive. So 13.5 gigabytes to 3.59 gigabytes. So with a not that much reduction in accuracy. And again, we use this approach, or use the output of these models a lot. So how do we do? How do we run an SLM on a CPU? We do this all the time. So I actually run it on this laptop, which doesn't have a GPU. So I do this quite a lot. We use it on Macs and other things as well. So fundamentally, we use TensorFlow. So TensorFlow, we largely use PyTorch, but also llama2.cpp. So if you've ever used those, that's actually a very good way of doing that. We set the right model based on the type of task we want. We typically use quantized models around that. That's our first port of call. We download them. We then use libraries like transformers, 𝗏transformers, and LangChain, and we basically then do the data processing, run the model, and evaluate performance. Classic kind of way of doing AI, but it takes us like sometimes one or 2 days to build a model or build a whole kind of component on this, which is massively accelerating on that. Cost comparison. So again, this is part of the thing about how do we actually do it on GPU rather than on small amounts of GPU. There's an example actually. We did a benchmark of this when we wanted to train a Llama 2 70 billion model, non-quantized. The 70 billion model is in 140 gig in memory, and if when you start training, it goes to 1.5 to 2 times, that's like 200 gig, 300 gig. Training time can take weeks to months, and if you look at that as a kind of raw cost, you want 2 boxes really because you don't want one to fail. You're talking about 200K a year. If we then take a smaller model approach, actually it reduces down quite significantly. So actually you can start putting these really commodity kit, like I say, you can do it on a Mac, you can do it on a consumer grade GPU box. Even on the equivalent EC2 or on AWS, you talk about 20K. So it's almost like a fifth of the cost of 2 boxes around that. And your training time goes from minutes to days rather than weeks to months. So again, there's a lot of advantages to doing that fundamentally. So we've talked about how we do this. What are all the typical tools we use? Hugging Face is like the go-to place for finding the models going to the platform. We use this all the time. LangChain, core Python framework for chaining stuff together. Which again we use quite considerably. We use Gradio as well, which is a really cool kind of front end for doing kind of fast prototyping of training. Looking at the errors and that type of stuff. 𝗦𝗰𝗹𝗋 typically we use as an open source database, but we do use the face vector capability of LangChain, which is what we use for that, and obviously 𝗍𝗵𝗏 for doing the simple front end around building up those language models as well. So this is typically our kind of core stack. So I don't know how we're doing for time, but
we're good. You can't.
Cool. So it's just in summary. 3 things I take away from this. Composability, this way of composing small data product thinking around a composable enterprise, around gluing stuff together rather than kind of one big thing. SLMs, hopefully this is giving you a small induction in kind of why SLMs are so good and what they're really good at. But they're cheap and they're cost effective, but you must be focused and actually understand what they're good at. And fundamentally, again, coming back to the business framework, this is super important. We start with a business problem. We work through the business process, work out where the opportunities are for small language models to participate as an overall outcome. And we use SLMs, not just SLMs in tandem. We use it with other data products in there as well. So yeah, that's it. So questions.
Your excellent presentation. That was a fascinating webinar. I particularly like the real world use cases. So I thought they were really helpful. And I think some of the questions might dive into those a bit more. So we're going to go through the questions as they came in. And I believe we can actually put them on the screen today, which is from Michael here. Can you pull data in real time or iteratively from secure data capsules like solid POBs for RAG, RLHF, and fine-tuning SLM?
That's a great question. So let me just understand from secure data capsules like solid pods for RAG. Well, obviously with RAG and reinforcement learning, the data sources are that's kind of separate, right? So fundamentally, if you want to bring data in from from wherever, really, for secure pods or from secure zones and that type of stuff, you bring it in. As long as you've got the connections, and also if you can deploy those small language models into those secure pods, which is really important, right? So you can deploy that. So if you can't bring the data out, you can only bring the weights over, not the actual data. You can deploy them in. So yeah, absolutely. The idea is that with small language models you can actually get to do that. So yeah.
Right. The next question is from Dan, who says, "What kind of analysis are you doing on invoices?"
So I need to be a little bit careful around, it's their IP. So, but yeah, we've got a number of customers doing analysis. Some are literally picking out the data, from that time, and some are actually then building out, looking at forecasts, look at actually, matching that with other, with like price benchmarking, that sort of stuff. So, there are a range of different things that happen from like very simple use cases to much more sophisticated. And what's interesting is once you start bringing the data in and actually being able to join it, using things like BERT topic and stuff like that, you start actually using metadata management with AI. You can actually get a much more kind of richer kind of connections between them. So, obviously if you're building knowledge graphs, you have to kind of do that statically, but actually here you're actually starting using AI to actually start creating, mathematical connections between the different data points. So, and also you're building that kind of foundation so people can actually think, oh, we can actually scan those in and actually see now we start seeing, proper forecasts, we can start seeing kind of what the buying patterns are, that sort of stuff. So that's, again, without going into too much detail, that's the sort of things that we see our customers doing.
The next question is from Michael again. Have you implemented solutions like LORAX to switch between SLMs?
Yeah, that's a really good question. So one of the things we did was for a customer was actually build a classifier. So fundamentally, we had almost like a chatbot, which is basically had people asking questions, but also posing actions and that type of stuff. We actually found small language models. They were you couldn't find ones that could fit them all. So what we did was actually build a classifier in front of that, saying actually what type of thing are they asking for, what type of action, that sort of stuff. We trained it on some of the data, and actually then routed that to different language models based on that exactly that type of classifying piece. So yeah, again, a very good question, because that really is one of the, if you're looking at small language models and small AI models, generally they tend to be targeted, so you need to be able to route them through. Yeah.
The next question is from Dan again. Any best practices on when to use traditional AI versus Gen AI?
Another great question, Dan. Thanks for that. Yeah, so this is actually quite key in my mind. The first bit is really understanding how they work. I mean, it's the same for everything. You take a step back. It's not technology. It's not an algorithm. You're doing data science. You're working out the class of problem that you're trying to do. You're trying to fix or trying to solve. And that's from a business perspective, but also from a data architecture perspective, and a data science perspective. So is this a classification problem? Is this a regression problem? Is this a graph problem? This kind of stuff. So understanding which type of models are actually good at those sorts of things are really, really key. So, fundamentally, that's the best practice, I would say. Fundamentally understand that. So, the way transformers work, typically they're very good at, picking up the next token based on a pattern that they've encoded into the vector database. So the dimensionality around that's what they're very good at, right? They're not going to be very good at actually, some use cases around that. So not very good at time series forecasting, although I have seen some people attempt that on LLMs. They're not very good. So I'm going to use a time series model around that fundamentally. So again, understand the problem space that you're in first of all, and then work out based on your knowledge of the particular algorithm, particular types of models to use that. Then you'll find actually your most business problems actually break down into a number of different these, and then you kind of glue them together as we showed earlier. So yeah, great question.
So the next question is from Mark Clare, who says, what's the underlying pipeline process that orchestrates all of these steps?
Yeah, another great question. So we actually, it ranges from, you stitch them together using Python, or we have done some for using kind of classic, orchestration tools like, 𝗏𝗏 and even I think we even attempted one on Airflow. But we've actually also built some stuff custom ourselves, because actually what you're doing is you're calling out to APIs rather than calling SQL engines. So yeah, we've actually hand-cracked some of those pieces, because you need to like say you're calling out APIs, and you'll need to be able to do things like state management, and so and also be able to not necessarily roll back, but understand if one breaks where you are in the process and stuff around that. So it is more like service microservice orchestration rather than kind of data orchestration. So that's really because obviously the models actually have different different APIs and that kind of stuff. And also, if you're prompting, you might have a prompt chain in there as well. So you can, things like LangChain to actually put them together. But again, you need to understand how that orchestration works. So, yeah, great question. Thanks, Mark.
The next question we have is from Brandon, who says, beyond parsing, triplet extraction, etc., are you seeing any valid use cases for SLMs in production currently?
Yes, yeah, absolutely. So we've done a number of use cases. One, actually, we worked with a very cool AI startup that was generating job adverts. Again, can't talk about too much around the IP around it, but yeah, fundamentally the idea is that it takes a recruiter an hour to generate a job advert that's diversity inclusion and sort of SEO, that type of stuff. And I work with an organisation where they built a model which actually took in the adverts and actually generated a new job advert which actually had, was diversity included. It's a limited number of bullet points. It was SEO, all that type of stuff as well. So it was a really good generative use case. We did another one, the one around the credit ratings. That was generating a report. So fundamentally, it's not about trivial factors. Actually, that generating a report. And there's a range of other ones as well around kind of personalization and that type of stuff as well. So yeah, good question. But you're right. There's the path from ideation to production is actually quite a long one. Again, understanding kind of it's a whole end-to-end solution is super key. But yeah, the sort of data extraction is quite a popular one because it's quite an easy, quite low-hanging fruit, and quite easy to automate. But there are other ones in as well. Great question.
We don't currently have any other questions. If anybody wants to submit some, so we're going to give you a couple of minutes in case you do. In the meantime, I'm going to ask Jon one. He's going to be scared. Which will be, are there? We've talked about the benefits of these, and clearly we've delivered solutions. Are there any particular challenges in building these that you can think about or share that were difficulties that you overcame and lessons learned from this approach that you can share with the audience?
So yes, it's a great question. So. One of the big things is hallucinations, and it's funny. I learned that word in terms of AI about 3 years ago. It's like, what's a hallucination? But that was one of the things we we struggled with one of those early BERT models. We had a particular use case where we wanted to extract out company names and people's names and stuff like that. And there was a particular use case where that couldn't be pushed through. And those company names and stuff could be anything. And sometimes if the model would actually spit out a company name or a person's name that wasn't in there, or it would instruct it to take it out and it didn't, that type of stuff. So this again, it comes back to the whole kind of accuracy piece, which is super important. So understanding how the models work, and actually that they can hallucinate, the fact that you're picking out tokens by random, the top P or top K type approaches. Understanding that, so constantly tuning the model, because some people think it's all about the data, but that's actually about you actually train the model. So you've got to find the edge cases, you've got to find the pieces that the flow throughs, and then you're labeling, you're kind of doing back propagation, that kind of stuff as well. So that's the biggest change. I've done a lot of work kind of on the software side where you have like a requirement and I can do a test, you can test against it. With data, with models, it actually gets much more tricky. So it's much more probabilistic. So that sort of mindset is one of the biggest hurdles.
I think we're getting a few thank yous for the session, and we'd like to thank everyone for attending. There aren't any other questions, so I think we'll say thank you all very much, and I'll just hand over to Jon.
Brilliant, thanks, Stuart. Yeah, well, thank you for attending today. As I say, we tried to keep this a little bit shorter. That's sort of popular demand. So obviously, if there's any questions, just give myself or Stuart a ping. Jon Cooke at 𝗏𝗏𝗏𝗏𝗏, Stuart at 𝗏𝗏𝗏𝗏𝗏.com. And yeah, love to field your questions if anyone had more thoughts around it. So absolutely come back to us. So I really appreciate you joining today. So yeah, everyone have a good day, night, morning, evening, wherever you are. So thanks a lot.